When I was working on the project, one of my biggest fear is looking my work. So I am constantly saving my files and making backup. When I was starting out, I would manually make these copies by adding a date, a version number, or a short description to the end of the file name. But managing these different versions was just turning me out the digital pack rat. I had all these different files that were just taking up space. I didn't want to delete them just in case I needed them again. And if you have ever created a file called version 1, version 2, and final version 3, then you know this method can be hard to manage. And if something were to happen to the hard drive, I would lose all of those carefully crafted files. But then I discovered the version control system, which are the tools that are designated to handle this for us. I am Ali Raj, and over many years' experience working as a developer, I have tried out a lot of different tools. And in this course, I will be discussing how to use Git to streamline your workflow, starting from installing and configuring Git, the overall concepts and terminologies, adding and tracking changes, and managing your project file. By the end of this course, my hope is that you will feel comfortable with the Git workflow and excited to start using it in your project and never again have to deal with the file name version 3. Let's start it. What you should know. In this course, no prior knowledge of Git is required, but I would suggest having a basic understanding of programming or you have think around with a website or two and make sure you feel comfortable downloading and installing softwares, using a text editor and working with the file systems. To Git and version control as a variety of using, this course will mostly focusing on using version control in context of being a programmer. Throughout this course, I will be using a Mac computer, but it is not the requirement. You can follow along using Windows, but just note that there may be some differences between the operating systems. In this course, we will mostly working with two tools, the command line and the source tree app. So the exercise file only contain a basic website template and a Git cheat sheet. You will also download these exercises from my Bitbucket account on Ali Raj Malik 7 and it's located in my Programming Foundation Git project folder. To download the project file, select download and then download the repository. Why you need version control? When you are working on any type of document, what do you save your file? To retain changing, right? But every time you save a file, those updates override the previous version. If you need to go back, then you can only undo so many times. So if you have ever had to create multiple versions of the same file to track your changing or to have a backup copy, you have created a rough version control system. Using this method or workflow for building a basic website might look little something like this. First was created by creating an HTML file and some code and content to it. Then we take any other revision to the HTML file. We want to keep the first version just in case we need to go back to it. Then we will add a CSS and JavaScript file. And note that we have received the final copy for this website. We feel pretty confident about deleting the version 1 HTML file, but we are not ready to get out to version 2 just yet. So make any other copy for the updates and call it final. There is no change to the JavaScript file, so we can leave it as it, but we want to experiment with some CSS. So we make a copy just for testing. Unfortunately, there has been a change to the content, so now you have to update your HTML file, which you have previously thought was going to be a final copy. You then finish with your CSS experiment and it works. So just name it V2. At this time in this project, you have a bunch of extra copies and some naming convention that may be sometimes confusing. And this is a pretty much basic example. Most projects will have many more files with the actual version control system. File management is a lot more organized. In the next lesson, I will look at the same workflow but with the version control system like Git. In the last lesson, we look at what a makeshift version control workflow would look like. I manually managing your file version. When using an actual version control system, also referred to as VCS for short, the system itself will track the changes within the same file. So I do not have to keep a bunch of extra copies. Let's look at the same workflow but with the version control system like Git. I started with the first version of the HTML file, then we made a change and created a second version. With VCS, the version history is tracked within the same file, so rather than having multiple copies, each version is basically a snapshot or the current state of all the files within this directory. Using a concept called commit, so if we add a CSS and JavaScript file in the next change, those two files and the existing HTML file and its version will be including as one snapshot in the revision history. In the last example, I made any other change to the HTML file while simultaneously experimenting with the CSS file in a separate area. With version control, this is called branching. When the CSS experiment is complete, we can merge back into the main version history. This will now include the new CSS file and the change made to the HTML file captured in the same commit. If this all free a little abstract still, that's okay. I will be going through each of these concepts in more detail step by step throughout this course. What is Git? Git is version control system, but it's not the only one. There are other popular options such as submersion of the mercurial. To understand why programmers use Git over other VCS, let's talk about the different types. While all VCS are used to track and create a history of changes, there are some differences depending on the type of model they follow. There are the two types of model, centralized and distributed. Subversion is an example of centralized VCS. All of these project file and the version history must be stored in the central server. To make changes, you check out the file that you need and work on it locally on your computer. Once you finish your changes and push back into the central servers to update the project file and the version history, using a centralized system is much better than manually making different copies of your files. But there are some restrictions. To work with the file, you must be connected to the server. And since you only check out the file that you need, make changes that you want. But you won't have a full copy of the project file locally. So if something happens to the server or you cannot connect to the server, you won't be able to access your project files. Git was released in 2005 and belongs to the newer distributed version control model which addresses some of these issues. In a distributed system, the main difference is you can have a copy of the entire directory and a version history stored locally on your computer. You can also use a remote server to designate a central location. That way, it can be accessed from any computer and be shared with the others. But it's that not required. The only time you need be connected to the server is to sync the changes between your local and your remote directories. Version control systems such as Subversion are still in use, but many developers have moved to a distributed model because of its flexibility. And while there are also other distributed version control systems, this course will focus on how to use Git to manage our project. Command lines versus uses. When we are on Windows or Mac, we communicate with our computer using the operating system interface. In computing, this is referred to as the shell. We can access the shell using the graphical user interface or command line interface. The graphical user interface, also referred to as the GUI, and it is the most common way to access the shell. We use the operating system icons, menus, buttons, and other graphics to perform actions such as operating file or resizing windows. These commands are executed using a mouse, keyboard, stylus, or touch screen to drag, click, or tap on these graphics. We can also access the shell using the command line tools such as the terminal on Mac or PowerShell on Windows. These tools don't use any graphical representation. Instead, we use only text-based command to execute version action. The interface kind of looks like the tools we see hackers use in these movies, but that's not what we are doing in this course. The command line is simply a way to directly communicate with your computer. Git, like many other types of software, can be used with the GUI or the command line. Personally, I like using a GUI, but it's a good to understand at least the basic of command line to understand the process behind what the GUI is doing. This will help you get up and running faster and enhance your workflow rather than using the tool to be a crutch for learning and fill in the gaps of knowledge. In this course, I will start by learning how to use Git with the command line and then I will look at how to use Git with the GUI. Git concepts and terminology. While learning Git, there will be some chicken or egg problem. Should I read up on all terminology and command first or just jump right into it? I personally think it's a good idea to start with a general overview of key concepts just to get a big picture of how it all works. I won't cover all the Git vocabulary right now, just a few common terms to get us familiar with this process. I have talked about the version control system as a tool that manages different versions of your file. and since they are often used to manage the source code for development projects. You may also see it referred to as a source code manager, abbreviated as SCM. A repository or a repo for short is not only the directory which contains the project file, but also where the Git stores all the information about the track changes and the revision history. Repository can exist locally on your computer or remotely on the hosted server. To track the changes in the repo, Git uses commit. To get version history is basically a series of commits which contain snapshots of all your project files and the changes. It's kind of like saving a specific point in a video game or taking a picture of specific moment. All that information about the point in time is recorded and available for review. Commits are pretty important in Git. A branch refers the different lines of development. By default, there is always one branch called the master branch, but we can create a new branches, often referred to as the feature branches. This makes it possible for multiple people to work on the same file at the same time. I also have created a cheat sheet which contains the terminology we discussed here as well as the other terms that will be the reference throughout the course. You can find the cheat sheet file in this description of this video. You can also download the exercise from my description and keep it close by hand and feel free to add notes to it. If at any end of this course you want to dive a little deeper, you can view a more comprehensive list of terminology in the Git reference document or check out in the comment section below for more videos on Git. Hosting services. I talk about the Git being a distributed version control system, meaning that a centralized remote repository is not required. But if you are anything like me and worry about losing your work, I would recommend using a remote repository to have a backup copy or to share the file when working with others. Also, I need to switch between my laptop and desktop computer all the time, so saving file remotely allows me to work from any workstation. If you want just a backup of your file, you can use a cloud service like Google Drive, Dropbox, or Sync. However, these services only offer file synchronizing, but there are also hosting services specifically for version control systems. These services provide additional features that go beyond file synchronizing, such as wiki issue tracking, hosting private or public repository, and a variety of collaboration tools. The features may vary among different services. Some popular options are GitLab, GitHub, and Bitbucket. When you are starting out, you probably won't need a lot of these features, or you may not even be sure what you need yet. It's okay to try a few of them out and see what works best for you. There is nothing keeping you from moving projects from one services to any other or using a different services for different projects. You can use any Git hosting services, but in this course I will be using Bitbucket. If you don't already have an account, take some time now to sign up for free at bitbucket.org. Git workflow. Git offers a lot of features, so there is a lot of flexibility in how to manage your project. Your workflow and the feature you may use will likely depend on the factors such as whether you are working alone or with the team or the scope of the project. So there is a no one standard process for how to use Git, but at its core, using Git is most about creating a series of commits. So there is a basic workflow that every Git user need to understand. How to create a repository and how to create a commit. Each step requires running a specific Git command. If you are using a GUI, the workflow remains the same. You will just be using a graphical interface to carry out these actions. I will be go through a specific Git command and how to a GUI later on this course. For now, let's talk about what the overall flow looks like. Step 1. Create a repository to hold your project file and initialize Git to start tracking your files. Step 2. Make your changes. This can be any type of change, creating, editing, deleting, or organizing your files. When using Git, saving a file is a little different from traditional editing tools. It is a multi-step process that may include one or more files. You are also required to first add the file. Step 3. When commits the file. Step 4. And finally, Step 5. Repeat Step 2 to 4 as many times as required. With the Git repository, these steps take place in three areas: the working directory, staging area, and the repository. Git using an internal state management system. So each of these steps are applied to the same file. You don't need to physically move these files to the different areas. The working directory is where you do all the work, creating, editing, deleting, and organize files. You can save these files as you normally would, and when you are ready to take the snapshot of your current directory, the revised files are moved to the staging area with the git add command. Adding files to the staging area is basically creating a list of revisions to be committed to the repository. This step is kind of like putting items in a shopping cart. You have the intention to buy these items, but the transaction won't be complete until you actually purchase them. Until then, you can add or remove stuff from your cart or staging the area until you are ready. When you are ready, you can move on to the final step, git commit. This step will move the stake file to the this tab will move the stage file to the repository. When you make a commit, the snapshot of your directory is now added to your version history. Every time you make a change, start the process again. Make your revision in the working directory, add the file to the staging area, then commit them to the repository and repeat as needed. While Git has some features that allow us to reverse or amend commits, it doesn't have the traditional undo or delete commit option. The points of using Git is not necessarily to create a perfect portrait of your work history, but to capture all the changes and specific points in the project. If you are newer on Mac, Git may already be pre-installed, but it's a good idea to reinstall it to make sure you have the latest version. First, go to the gitscm.com/download and select the Mac operating system download. It should start automatically. If it doesn't, select the click here to download manually link and it will take you a new page. I have already downloaded it, so I am just going to into my downloads folder in my finders. Let's start the installation by opening the DMG file. Once it's open, we will see a few items. The readme test file has some additional information about the install. But we can just go ahead and double click on the package to install Git. If you get a pop-up message that says it can't be opened because it's from the unidentified developer, we will need to go out the system preferences, selecting security and privacy, and since that we know that this is the legitimate download, we can OK this section. So select open anyway and select open again. Now the install has started. So I am going to select continue to go through the installation. Select install to go to the next step and put your computer password. And the installation is complete. Let's move the DMC file to the trash. Now that it's complete, we can verify the installation using the terminal. It can be found under the application and utilities, but I always forget where it is. So I like to open it using the spotlight search. Once open, run the command git dash dash version and press enter. The output will show the version number. At the time of this recording, the version is 2.230, but you may see a different version depending on when you do the install. If you downloaded this from the Git site, it will be the latest version. We can also run just git has the command and the output will show some basic information about the Git. We will be go through more of these commands throughout this course. To download the Git software, go to the gitscm.com/download. Select the window option. The download should start automatically and if doesn't, select the click here to download manually. Let's go to the download folder and start the information. Double click to start the installation. On this screen, choose additional icon if you want to add shortcuts to your desktop. And for the next two options, Git Bash and the Git GUI are the alternatives for using Git rather than the default program PowerShell. Even if you are not sure if you will use them, you can keep these options checked out to include them in the install. You may want to try them later on, and for the next three configuration, just leave the default option as it is and you can leave the last two unchecked unless you want to use a true type run or Git updates. In this step, if you are not sure which default editor to pick right now, then no worries. This setting can be changed later on. Now let's stick with this default setting. This is recommended because this option will allow you to use Git with different command line tools. This screen is a setting for how to communicate over a secure connection while using Git. If you are not sure, the default OpenSSL library should work for most developers. Whatever you choose here, it can be changed later on. Here we can configure how Git will handle the line addings. This may not be an issue if you are working by yourself, but Git tracks any change made to a file, even it is a different in formatting. This option will support both Windows and the Unix style line endings. If you are not sure why you need, just stick with the default. We can stick with the default here again as well. This will allow us to use different command line tools, and for the extra option, you know what we are going to do. Leave the default option, and for the large screen, this is the configuration of experimental options. No need to check this, let's focus on the basic first. Okay, the install is almost complete. This may take a couple minutes, but I will speed up this portion of this video so you don't have to sit there and watch my install. Know that the setup is complete. Let's verify the installation. You can choose to launch this newly installed Git Bash tool from this screen, or you can use PowerShell, which already comes with Windows 10. You can find this program from your start menu, and if you don't see it, you can also do a search for it. Let's run this command git space dash dash version to see the version number and also verify the installation. Now that we have verified the version number, you are ready to get started working with Git. Using the command line. One way to use Git is with the command line tool. If you haven't used the command line before, it does take a little practice. Because instead of clicking on an icon to open a program or dragging a folder to move it to any other location, each action requires typing out a specific command. It is kind of like writing your own code rather than using drag and drop software. Command line tools such as Terminal on a Mac and PowerShell on Windows don't have any graphical representation such as buttons. Instead, all the interactions are based on typing out specific commands. While not required for using Git, many developers prefer the command line because in some cases it may be easier or more flexible for performing certain actions. Even if you decide to use a GUI, it's a good to have a general understanding of how Git works using the command line. Plus, the command line is only the place you can run all the Git commands. Git GUI provides useful visualization for many Git commands but may not incorporate all of the functionality. I would recommend going through both the command line and GUI exercise of this video before making a final decision. So you may find that you prefer one over the other or a little bit of both, which is my personal preferences. Before we get into Git specific command, let's get familiar with the command line in general. I will be using the terminal on Mac. If you are using PowerShell on a PC, some commands are different on, but the ones we will be using in this course should be the same. When we first open the command line, the first thing I will see is the prompt. This is where we enter and execute command. The way the information in your prompt may be displayed different from mine, but the information itself is the same. In my command line prompt, I can see my computer name, the home directory represented by the tile, and the username. If you are not seeing your current directory, we can run out first command pwd, enter or return to execute the command. This stands for printing working directory, and I will output the full file path of our current working directory, which is user and my username. What I can see in the command line is similar to the opening your Finder or Window Explorer in the home directory. To see the content of any directory or folder, these terms are interchangeable. All you have to do is select it. To see the contents of any directory or folder, these terms are the interchangeable. All you have to do is select it. To see the content of our current working directory using the command line, run the ls command to the list the contents. Output shows a list of folders contained within your home directory but doesn't list all of these hidden files. To show all the content including the hidden directory and the file, an additional argument -a can be added. ls space -a arguments are basically extra commands used to run the different options. The folder in your home directory might be a little different from mine, but we should all have in the desktop. So let us change the directory command, and to move into this directory, cd space, then the directory name. You can type the whole name or press the tab key to autocomplete the directory name if there is a match. So I will type dtab. If there are other directories that match to the same character in the terminal, the output will list all of these matches. In PowerShell, it will go to the first match using this tab shortcut in the terminal in case sensitive, but manually typing the full directory name is not. So I could type cd space lowercase desktop and it will change to the directory. But I would still recommend it using the accurate letter casing to take advantages of the shortcut features. We can also use the clear command to clear the screen if it starts to feel a little unruly. It doesn't actually delete your command history though. If you scroll up, you will still see it. Let's try one more command, mkdir. This stands for make directory, and we will use this command to make a new folder to store all of our Git projects. Well, you can use directory and file name with spaces. It can cause problem, especially with web-based projects. So as a best practice, sticks to lowercase letter in separate word with a dash or underscore. So let's add a space followed by the name that you want to give the directory. Let's call it git-project. You should now see your new folder on your desktop. This command just makes the new directory. If you want to move into this new directory, you have to cd into it. Cd space git dash project. Something to note. You can't use the mouse or trackpad to navigate within the command line, but you can use the left and right arrow keys to move the cursor. You can also use the up and down keys to cycle through past command. Pretty much any task you could do with the mouse or keyboard such as moving between directories or creating files and folders can all be done using specific commands. Which means there are a lot more commands, but I have gone through a few common ones to get up and running. For the remainder of this course, I will be focusing on Git specific commands. There is one more thing to note about working with the command line. Some command won't result in the new prompts following the output. So if you find yourself stuck or need to go back to the prompt, you can usually type Q for quit or escape key. You can also write the command Ctrl plus C, and if all this fails, just restart the app to start a new session. After installing it, the first thing we need to do is configure some basic settings. Using it means adding a bunch of commits, and each commit is associated with the author identity, a username and an email address. This information is useful when working with other people. Also, if you try to add a commit without configure the setting, you will get some messaging that will ask you to verify or add username and email. To add your author information, use the git config command. Next, add the dash global argument to set the configuration globally. Then add user.name or user.email and your detail in quotes. This information is just used as a label. It won't trigger any emails to be sent to you. And if you have concern about privacy, you can use any name or email address. Let's go back to the command line and add this setting. We have been changing directory. So far we are no longer in our home directory. But that's okay by using the global argument. It doesn't matter what directory we are in. Global will automatically set this configuration in your user home directory and can be applied to all of your directories and can be applied to all your repository. Let's start by adding user.name and then add your name in quotes. You can include spaces in uppercase or lowercase letter. Just make sure to keep it within these quotes. I am just going to set my username as just so that I know any commits I push from here is coming from my desktop. Enter to execute the command, and now let's add in your email. I could just type out the whole command again, or I can use my up arrow key to cycle through the last command and just tilt up to the user and add in email. And here I am just going to use my test account. This information only has to be sent once, but if you want to change what you initially set, just run the same command again. If you can run the command without any code test, your current setting will be outputted in the next line. If you want to use configuration for specific repository, change to that project that directory first, then run the same git fig username and user email command but without the global argument. This username and email will also be associated with this specific repository. There are plenty of other configuration that you can use to customize your workflow. I would suggest taking a look at this list in the documentation to get a general idea of what options are available. If you have never used Git before, it may be a little hard to tell you what you might need, so don't worry too much about this adding and any extra configurations. Right now, you can always change these settings later. Before we can do anything with Git, we need to first create a repository. I usually designate a main folder to hold all of my projects. Then create individual project folder inside. Let's use the Git project folder we made earlier to hold all of our exercises. And first, let's make sure we are in the correct directory. Use the pwd print working directory command to check where you are. The output tells me I am currently in my Git project folder. If you are not in the Git project folder, cd into it first. Here a little trick for changing directory. First type cd and space, then drag the folder into the terminal and press enter. I find this technique especially useful for avoiding typos or for typing out long directory paths. Also notice that when we see the full path for nested directory, each one is separated with a forward slash. This doesn't 100% using the command line since I am using the GUI to drag the folder into the interface, but I say use whatever technique works best for you. Okay, let's make a new project folder using the made directory command again, mkdir space, then the directory name. Usually, I would name it something descriptive like the client name or the domain name, but I am just making a test project. So I am going to just name it project dash a. Remember, this command only creates this directory. I will have to use the cd again to change into this directory. Now we have to run a git specific command to turn this folder into the git repository. The git init command, which stands for initialize, will set up all these tools that git needs to be tracking changes. This only has to be done once at the beginning of each project. Let's run the git init command in this folder. The output confirms that we have initialized the git repository. When we look in this project dash a folder, it's empty because we have not added any files. But how is this newly initialized git repo different from any other folder? Well, the tool that Git adds during this process is contained in a hidden directory. Unlike your pictures and documents, some files and folders such as system related files are automatically hidden because they should not be edited. But we can use the ls-a command to see the hidden file. Now we can see this git folder. By default, any directories or file that begin with a dot will be hidden. This git folder contains all the necessary files to track your repository. So we can access this folder, don't edit any of these files. Any git specific action we perform using the proper command will update this file accordingly. Note that project A folder has been initialized. Any changes we make within this folder can be tracked with Git. To create a remote repo, you need to have an account with the Git hosting service. While there are many to choose from for remainder of this course, I will be using Bitbucket. To set up a new remote repository, log into your account and look for a create repository option. In Bitbucket, if you don't have any existing repo, you will see a create repository option in the landing page area. But you can also find it in the sidebar under the repository or under this plus sign. Let's create a new repository. Since I named my last project the project A, I will be call this one project B. You can choose to make it private or public. For the readme option, no will just initialize an empty repository. Yes, with template, we'll add a blank readme into the repository. And yes, with this tutorial, we'll add some get starting instruction into the readme file. Let's choose this option. Make sure Git is checked and create repository. It is a convention to have a readme file since it kind of acts as a home page for your repo. Usually, the README contains the information about the project such as contribution guidelines, usage instruction, credits and licensing or copyright information. And that's it. You have created a remote repository. With most version control hosting service, it is possible to edit the file from the browser. I can click on the file and select edit. This can be useful in some cases, but for the majority of the time you should probably work from a local copy. To create a local copy from a remote repo, we have to clone it using the git clone command. This will create an exact copy, but it will also connect the local and the remote repo, which will allow us to sync changes between the two. So let's go back to the main project B page and select the clone button. We have two options to choose from the repo URL HTTPS and SSH. Whichever one you can use depend on how you can authenticate your account. And since we haven't taken the extra step to set up the SSH key, we will choose the HTTPS option. In Bitbucket, the git clone command is included here for us to copy. If you are using any other service that doesn't include the command, just make sure to add it in the command line before the repository URL. Let's copy the whole line. Let's go back to our command line. You can't have a git repo inside of any other git repo. So we can clone this into the project A folder, but we can add it in our main project folder. I am still in my main project A folder from the last exercise. So I am going to use cd space dot dot to go up a directory back into the parent directory git projects. Now I can run the git clone command. You may be prompted for your Bitbucket password, and as you are typing it in it, it will look like nothing is happening because the cursor doesn't move, but it is registering your keystrokes. So just type your password in very carefully and press enter. Once the clone is complete, you will see the command prompt again in the project B folder in your local directory. Let's use cd to navigate into the project B folder so we can make some changes in the next exercise. If you would like to learn more about the differences between HTTPS and SSH authentication, check out this tutorial on my YouTube channel GetSiteman for more videos like this. After creating a repository, the basic Git workflow is mostly making, adding and committing changes. Let's start it by making a change to the README file in the project B folder. I already have the project open in Atom, but you can use whatever text editor you prefer. This file extension is MD because this is markdown file, which is the markup language used to add formatting to elements in a plain text document. The first line is enclosed by two asterisks on each end. This is the markdown syntax for bolded text. One asterisk is italicized text, and these two number signs will format this line as an H2 heading. If we look at the refill on Bitbucket, we can see how the README file looks with formatting. README can be written in any text file format, but Markdown is commonly used. To learn more about Markdown, check out markdownguide.org. I am going to go back to my text editor so we can make a change to the README file. I will start by deleting all the template text, then I will add a new title and use two number sign to create an H2 heading. The project description can be added as a paragraph. With Markdown, a paragraph doesn't need any special syntax. Save the file as you normally would in your text editor. Now I have made a change. I have something to add to the repository. If you close your command line from the last exercise, when you open it again, it will default to your home directory. So make sure you are in the project B folder first before running any other command. We can also run the git status command at any time just to see where it's going on. The first line says on branch master, which is the default and the only branch we have the right now. The second line says your branch is up to date with the origin/master. Origin refers to the remote repository, so it's just saying that the version history in our local and remote repository are currently the same. The next line says changing net stake for commit. Let's pause here and revisit the concept that we talked about earlier, the three areas within the repository. When making any type of change, modifying a file in a text editor, adding or deleting a file, or renaming it, this is happening in working directory. The staging area collects the revision that to save as snapshot. Then they are committed to the repository and added to the version history. To stage the revised file, use the git add command. There are a few different arguments that can be used to add specific types of changes. Dash capital A is used to stage all type of changes. A period add all changing except deleting files. Dash U adds all the changing except new files, or we can just add a file by its file name. I will go back to my command line and add these files. Since we only have one modified file, any of these git add argument can be used. I will use git add period and I will run git status again. Now that I have added the file, then the message says change to be committed, which means the readme file is now in the staging area. If you change your mind and don't want to save this change, use the git restore command as shown in the status message to unstag it. But for this exercise, we do want to stage the change. Let's move on to the next step. Committing a file will create a snapshot of this changes. Every commit requires a message, a short description of what changes are contained within the commit. The full command will look like this: git space dash m for message, and then the message in quotes. The output shows a summary of what has been committed. 1 file change, 3 insertion, 45 deletion. The output shows a summary of what has been committed. 1 file within 3 insertion, the new line, and I added, and 45 deletion, which was all text I deleted. Let's run git status again. Now it says your bunch is ahead of region master by one commit. This means that our local master branch has one commit that the remote region master branch doesn't have. The next line, nothing to commit, working 3 clean, means there is no modified file in the working directory. To sync the local and remote repository, there are two additional commands: git push and git pull. We will go in more detail about these two commands in the next lesson. Keep your command line open for the next exercise. When using a local and remote repository, there are a couple of extra steps required in the Git workflow. To make sure everything stays synced and up to date, Git push is used to upload the local commits into the remote repository, and Git pull is used to download the commits from the remote repository into the local repository. Let's look at the status message from the last exercise after adding the local commit. On branch master, refer to the local and default master branch. This is where we are currently. It also tells us the name of the remote branch, origin/master. Origin refer to the remote repo, which is also using the master branch. So our local master branch has one newer commit than the remote master branch, making it ahead by one commit. The status message also tells us how to sync them: git push to publish your local commits. To specify where to push the commits, use the git push command with the remote name, origin, and the branch name. Right now, we only have one, the default master branch, so the full command to upload the local commits to the remote repo is the git push master region branch. Let's run the command in the project -b folder to add our local commits to the remote repo. Right now, we only have one commit, but git push will upload all the commits that wasn't captured in the previous push. We should now be able to see the commits in the big bucket. In the Bitbucket repo, I can refresh my landing page to see the new commit that it is right in there, or I can check commit in the menu and see the version history. Here is the commit message we added, and the timestamp refer to when the commit was made, not when it was pushed to the repo. Each commit also has a reference tag associated with it. These number and letters that you see under the commit column, under the author column, the first commit show my Bitbucket author information. But I am using my colleague computer, that's why it shows this name, because I created the repo from this account. We save it as this first commit. The second one is Christina Desktop, that is the author username I added during the git configuration step on my computer. So this username is attached to the changes made from my local repository. If your repo is public or you have given other people access to your private repository, this will now be able to see your commit history as well. If several people are working on the project, or if you are working from a different computer, there may be a changes added after you have cloned the repo. Then you would need to update your local branch with the git pull. The arguments are the same as the git push, so the full command for this example is a git pull origin master. We won't be covering git pull in more detail since we won't really be using this feature for this course. But I just wanted to mention it in case you need it for the collaboration when working on a project. Don't be shy about committing often. You don't have to wait until a whole feature is done to add a commit. Maybe you have completed a smaller task or figured out a problem and want to make sure there is a snapshot of it. You can even make a commit based on a period of time, like when you break for lunch or whenever you are done for the day. As long as you write clear commit message describing changing such as edit base CSS style or project status at end of the day, you can commit whenever you want. Your revision history doesn't have to perfectly document the milestone of the project. Deleting a local repository is pretty straightforward, though you can do it with the command line. It's much easier to just delete the folder in your Finder. This will delete your local repo. To delete the remote repository, you must log into your hosting service. In Bitbucket, go to the project that you want to delete, then under Setting, find the Delete Repository option. Select Delete Repository to delete your remote repository, and that's it. Let's practice applying the different commands we have learned about so far in a challenge. Here what we are going to do. First step, go to the Bitbucket and create a new remote repository with a readme file. You can name the repo anything, but I will be naming mine personal site since it will be used for a basic personal website template. The readme file can be empty or contain content. Just make sure to include one. Then clone the repo to make a local copy. Once that complete, add some new file into the local repository. In the course exercise file, there is a template file for a basic website that you can use in the website template folder. Feel free to personalize the template file when you have moved the file to your local repo and finish making any modification. Add and commit all of these files to your local repo. Then update the readme file to include a description about the project and commit the revised readme file to your local repository. And for the last step, push both commits to the remote repo. Take some time to see if you can configure it out on your own. We are just working with the test repository right now, so there is no danger of messing up a real project. If you have to delete the directory and try again or do it a couple of times, that's okay. When you are ready to check your work, I will be providing the solution in the next video. Welcome back. I hope you were able to work through the challenge and get some practice. Let's go through the solution. Step 1. Create a remote repository. I will select the plus icon then repository. I am going to name mine personal site. I can leave this repo set to private since I don't need to share it with anybody. You can always change that in the project setting as well. And I will also include a readme, whichever yes option is fine. I have tried to clone an empty repository before in the past and run into the some problem. So to save you the headache, just include a readme file and update it later. Then we will create repository. The second step is to clone the repository to make a local copy. Let's click the clone button and make sure this is set to the HTTPS and copy this whole URL and git clone command. Then I will switch to my command line and navigate to my git projects directory so I can clone the repository in there. Then I will switch to my command line and navigate to the git project directory so I can close the repos here. I am still in my project -b folder from the last exercise, so I will use cd space dot dot to go back up into the parent directory, which is git project. Now I can paste the clone command in the press enter. If we look in our git project folder, we can now see the new personal site directory. On to the step 3, adding file into the local repo. I am going to move my website template file into my new personal site folder. Step 4, add and commit these changes. The git clone command clone the repo, but my location in the command line is still in the git project. So before I can add and commit these changes, I need to cd into my personal site folder first. I'm just going to run git status, which you can do at any time just to see what's going on. Right now it's showing that I have untracked files. That's because I haven't added them yet. I will do that now. I will use the git add command with the dash capital A argument to add in all new changes. Let's just run git status again. Now I will show that I have changes ready to be committed, which means that these files are now in my staging area. So now I can run the git commit command and I will add a dash m for message and a short description in quotes. Edit page website file and press enter. Let's just run git status again to see what changed. Note that I have committed this file into my local repository. The status message says your branch is ahead of region or master by one commit. So I have added one commit to my local, but I haven't pushed it into my remote repo yet. So I won't see it in one bucket until I push the commits. Before we do that, let's move on to step 5. Make a change to the readme file. I will open this file in my text editor and update it to include some info about the repo. I am going to delete all of these template tests and just add in a new title person's website. I can also a short description. This project contains the template for my personal website. You can even include using information like for personal use only or contact info. Any kind of detail that seem relevant to the project can be added here. Save your file and let's go back to the command line. Now let's add and commit this update. Git add dash a to the change. Git commit dash m for the message. Adding revised readme and enter. Now for the last step, push the commits to the remote repo. So far I have added 2 commits. If I run git status again, we are now going to see that I am 2 commits ahead. When I run git push, it will upload both commits. I also have to tell where to push to region, which refer to the remote repo, and master, which is the branch name. The push is done. Let's check the Bitbucket repo. And there is my two commits. There's a lot more we can do Git and command line, but we have learned enough to start incorporating version control in your workflow today. If you want to explore the command line a little bit more, I would suggest reviewing some of the lesson and going through some of the additional resources that I have referenced to in the description such as my tutorial or the Git documentation. Using GUIs. When getting started with Git, sometimes using a GUI may feel easier to get up and running with because the interface uses convention we are used to such as button and drop down menus. There are many free and paid options. You can see a list of available apps on the Git-SCM site. Even some text editors have Git integration such as Sublime Text, Atom, and Visual Studio. So there are also a variety of two command line tools and customization options. The command itself like git add or git commit for example remains the same since these tools are all text based. When using a Git GUI, the interface and feature may vary across different software apps. In this video, I will be using the source tree app and I would recommend using it as well to follow along with the exercise. I will be going through the installation in the next video. If by end of this course you decide that you like it, then great. If not, feel free to try out some of the other options or continue to use the command line. Sometimes you have to try out a few tools to figure out what works best for you. To install SourceTree, we first have to download it from sourcetreeapp.com and choose the option for your operating system. To continue with the download, you must read and agree to the Atlassian Software License Agreement and Privacy Policy. When you are ready, check the box and start the download. I have actually already downloaded it, so I am just going to cancel this here and go to my downloads folder. Double click to open it and then I will move it to my application folder and open it from there to continue with the setup. You may be prompted to confirm that you want to open it. Select open to continue. SourceTree is an Atlassian product which also includes Bitbucket. We have been using Bitbucket Cloud for our remote repos which can be connected in this tab. If you are using any other hosting service, you can add it later after installation is complete. So let's just select continue now and we will add our Bitbucket account later as well. Next we have the option to set the global author details for Git or the Mercurial, which is any other type of version control system that SourceTree supports. This setting is the GUI equivalent to adding these details with the git config command. Whatever you set here will override what you added earlier with the command line and select done. The installation is now complete. Now let's add our Bitbucket account information. I am just going to close my browser so that we have a clear view of the SourceTree app. Now let's click the gear icon and then accounts and then add. The host option will default to Bitbucket, but you can select the arrows and to add any other service. We have not set up any SSH key, so choose the HTTPS option for protocol. We haven't set up any SSH key, so choose the HTTPS option for protocol, then select connect account. The authorization process will take you back to the browser to grant access to your Bitbucket account, so select the Open Source Tree app button. Once you see your Bitbucket username appear, the account has been connected. Press save to complete the setup. Now we can see our Bitbucket account. Let me just close this browser again and we can take a look at the source tree list. Under the remote tab, we can now see our remote repos. From here, we can clone these repos, but we don't need to for this project because we already cloned them. In the local tab, the repository won't appear automatically, but we can add specific local repository by selecting the new dropdown and selecting add existing local repository. We can also drag and drop specific folder into the app or just scan a whole directory. Since we have all our project in one folder, let's scan the Git project folder. Click add repository and now we will see in it our local repo. If you are on Mac and see this pop up, Apple just want to save your password into our keychain, so enter your computer password here. Now we have a list of bookmarking pointing to our local repos. We can see project-a in the local list but not in the remote list. Because this repo was only initialized locally, we will get into more detail about how to work with the repos in the next lesson. Let's look at one more thing. Click the gear icon again and go to the account. Under Journal, we can see our author details. Since we left this blank during this setup, it pulled in the information we set earlier with the git config command. You can also change this detail here or uncheck this option if you don't want source tree to override the configuration added with the command line. There are many other settings, but most of these options touch on feature we have not got into it, but we don't need to worry about them too much right now. The basic configuration has been set. You can always revisit them a little later after working with the Git a little bit more. Also note that apps often get updated or changed, so this is how the setup instructions currently look on Mac at the time of this recording. If your setup is a little different, that's okay, as long as you are able to install the app and access the main features. In the last exercise, we added our existing repository to the source tree app. We can now move between our local repository by clicking on a project in the bookmark list. This is basically like changing directory in the command line. We can also create new repository with source tree app as well. Under the new drop-down menu, there are several options. Clone from URL server. The same function has a git clone command. Source URL refer to the repo URL. I have already copied one of my remote repository just for demonstration. Source tree now recognize this as a Git repo. This designation path is where you want to save your project. So our Git project folder and the name just refer to what you will see in the bookmark list. It pre-populates to match the remote repo, but the repository folder itself will clone using the same name as the remote directory. I have already cloned this repo, so I will just cancel this. But if I was cloning this repo, I would select clone to finish. Let's look at some of other options. Creating more repository allow you to make a repo in Bitbucket straight from the app. Add existing local repositories for adding a local Git project to the source tree, and the create local repository option allow you to create a local repo only. You also have the option of creating a remote repository at the same time. This designation path should point to where you want to initialize the repo. Remember when we created a local repository with the command line, we started by creating the folder first project-a, then initialize Git in that folder. We will do the same thing with the app. First navigate to the Git project folder and then from here we will create any other folder. I will name mine project-c. Now we will be select open to make C project. Now we will be select open to make project-c our new destination path. Select create. We will see any other screen for creating the remote repo for the Bitbucket info. The remote repo name will default to the same name as the local repo. You can use different name, but it probably makes sense to keep it the same. So let's select create again and that's it. You have now created a local repo and remote repo at the same time. We can see it in our local list as well as our remote list. This step not only initialized the local repository, it also created the remote repository and connected them. So you can start tracking your file right away and push and pull to and from the two repos. We have gone over how to add and commit changes with the command line. Let's look at how to do it with source tree. I have already added a bunch of different types of changes to the personal sites file, so to show how it represented in source tree, it's okay if you don't have these exact changes in your project. This is just for demonstration. In the repository list, we can see a notification which shows the number of file changes. Double click the bookmark to open the project. Here is a list of all modified files. The yellow box with the ellipses represent a modified file. We can see what's been changed on the right side of this app. The red represents the deletion, green is the new addition. I renamed the style.css file to main.css. So now main is showing with purple question mark, which indicate a new untracked file. Style.css is showing with the minus sign and is used for deleted file. We also created a new folder, images, and moved the sunset photo to it. This list just shows the modified file in the working directory. We can right click anywhere on the file or click the ellipses to see various options. But before I do anything with this file, let's go over how to customize the view. I find it easier to be able to see the file in both the working directory and the staging area at the same time. Right now, this list is being shown as a flat list. Let's select this multi-line icon and then change it to a tree view. This add a folder icon. We show that the image is contained within this folder and give a better visualization of directory and subdirectory. You can also collapse the folder as well, which come in handy if you have a lot of files. We also like to change the layout to the split view staging. Now the top left area will show my stage file and the lower area shows my revised file in the working directory. To stage a file, I can check the individual file boxes or I can just stage them all the same time. Notice how some of the icons have changed. The files that were renamed or moved are now shown with the R icon instead of showing as a new or deleted file. I am going to guess that R stands for revised or revision. I also did not really want to delete the readme file, so I can actually unstack this file by unchecking it. I can even reverse the deletion by clicking the ellipses and choosing the discard file option. The term discard sounds a bit misleading because to me it sounds like it's going to be deleted. But in this context, discard just means reversing whatever changes was applied to it, so it will be reverse the delete and put it back to what it was before you change it. We no longer see it is in working directory because we discarded the change, so it's nothing to stake or commit. After the files are added to the staging area, we can now commit the change. Add our commit message at the bottom of the screen, and we can also check this box push changes immediately to origin master to push the commit up to the remote repo at the same time. If you leave as an unchecked, you can always push the commits up later using this push button. Let's press this commit button to finish this setup, and that's it. Let's say you are adding a new feature to a project that will take some time to build. You start working on it right away, but a week into building this new feature, a bug has popped up. You need to fix this bug right away, but the code you added for a new feature is not ready to go yet. This scenario is a perfect use case for using branches. With a Git branching workflow, the master branch is designated as a central repository. Instead of working in and committing directly to the master branch, all work is completed in separate branch. For example, each new feature will be developed in the designated feature branch and bug file will be updated in a big fix branch. Each branch is an independent line of development and Git makes no technical distinction between the master branch or any other branch. So we can apply all of the same Git commands to any of the branches. Once the work in the branches has been completed, tested and deemed ready to go, it's then merged back into the master branch. This process will ensure that the master branch will only contain the most up-to-date and stable code base. This workflow is often used for large projects and teams, but if you are working by yourself, even it is a small project and basic branching workflow is still beneficial. So let's go over how to create branches with source tree. We will continue to work with the personal side project. To make a new branch, select the branch icon and give it a descriptive name. Let's say I want to make some design update to the site. I can create a feature branch and call it redesign, or I can even more specific and call it theme update and use it just for changing related to the visual like colors and fonts, but no changing to the content or functionality. The default option is to create the branch from the working copy parent, which means it will make a copy from the master branch. You can also choose to make a branch from a specific point in the commit history by selecting specific commit. But for this demo, I will stick with the default. Check out new branch, just name it, that will switch into a new branch working directory after we create it. Let's create this branch. We can now see our new branch under the branches menu in the sidebar. The black circular icon indicates which branch we are currently in. If you want to switch to any other branch, you can double click on it or right click on the branch to open any other menu or select checkout. Make sure you have got your theme update branch checked out before we make an update. Here how the project looks right now. It doesn't really matter what changes you make for this exercise since we are just working on a test project, but I did create an theme update branch, so I will make some theme update to the CSS file. On line 15 I will remove the border. On line 18 I am going to change the font size to 3.5 rem, and for the h2 on the line 21 I will change this to 2.5, and then I will save the file. So now we have some changes in the branch. Let's go ahead and commit this update just like we have been doing in the previous exercise. Under file status, check the main.css file to stage it. We can also see our deletion and addition on the right side. Now let's add a commit message, add a theme update. If we choose to push this commit to the remote repo, it won't go onto this master branch. Notice that it says push changes immediately to origin theme update. This means the whole branch will be added to the remote repo. So if you are working with somebody else or on any other computer, you will able to access the feature branch as well, the master branch from the remote repo. Let's keep this option selected and commit to complete this step. Now when we go to the repo and Bitbucket, we will be able to see the branch from the drop down menu. Let's refresh this page first, and in the drop down there is my branch. We can also see commits specific to each branch. If I click on the theme update, I will be able to see the commits made to just this branch. If I switch over to the master branch, I will no longer see the commit because it's only see push to the feature branch at this time. So we see the separation of branches. Git doesn't physically create a new directory from each branch. All of these actions are happening to the same file. Let's go back to the source tree and check out the master branch. Now let's look at the main.css file in your test editor.
those changes we added in the branch. Remember, I removed this border. I changed the font size to these two headings. Well, we can no longer see those updates because we are in our master branch. Those updates were only created in the theme update branch. This is why branching is so useful for working on different updates at the same time. I can do theme updates in one branch, bug fixes in any other, and content update is yet any other branch. I can switch between them as if they were completely separate directory. Just make sure to commit your changes before switching branches. Once the work is completed in feature branch, we will need to merge it back into the master branch. We will talk about how to do that in the next lesson. When the branching workflow is being used, the master branch is usually designating as the central repo, where the latest and most stable code base is stored. Feature branches are created for the in-progress work. Once the work is completed in the feature branch, it's then merged back into the master branch to keep it up to date. To merge a branch in this example, our theme update branch, start by making sure you have checked out the branch you want to merge into the master branch. If you don't see the black circular outline next to the master branch, then double click on it to check it out. Then we will initiate the merge by clicking the merge button at the top of the app. A pop-up will appear, highlight the laser commit from the theme update branch. This is to indicate which commit to merge into the master repo. Then other options select the first three. This first option commit merge immediately if no conflicts. This just means that if there is a conflict between changes in the theme update branch and master branch, the file will not be committed. The conflict would have to be resolved first. The second option just includes the commit messages from the feature branch into the commit containing the merge. And the third option, we want to keep this checked. This is a more advanced concept that we won't explore in depth in this course. But basically, fast forward means if you try to merge just one commit, Git may try to simplify how the merge will appear in the version history. Let's click OK. Now let's look at the commit history. This red line in the graph represents the theme update branch. We can see that it originally split from this main repo when we created the branch. The one red dot references the one's commit that was added. This was added to this branch away from the master branch, and note that it's merged. The theme update branch is pointing back to the master branch. This is all still happening in our local repo. The label says master 2 ahead, which means our local master branch has 2 commits more than the remote master branch. So let's push these commits up to the remote master branch using the push button. Just keep the master branch selected. We will only select the theme update branch if we wanted to push a change up to the remote theme update branch. Press OK. Now the commit in the branch has been merged into the master branch. Now we can see the label in the commit show master, our local and original master, the remote repo, and all in the same commit. If we look at our repo on Bitbucket under the commits, we will be able to see the changes from the branch as well as the merged commit. Let's refresh the page to see the update. Here our merge commit and here the branch commit. Now if you are done with the branch, it can be deleted. If you want to continue to working in the branch, then leave it as it until you are done with it. To delete the branch in source tree, right click on the branch and select delete. In this pop-up, the force delete option means it will delete the branch regardless of its push and merge status. Our current example only had one commit which we already pushed in merge, so it won't affect us. Select the delete remote branch to delete both the local and remote at the same time. For smaller project or if you are new to Git, this basic branching workflow will be enough to get you up and running. To learn more about advanced branching workflow or using branching with the command line, check out the comparing workflow tutorial on the Atlassian's website. It's time for any other challenge. In this video, I have gone our way to achieve the same task we initially used the command line for, but with the source tree. In this challenge, I will do more for that. But I will also get in some practice working with branches. We can continue to use the personal side project for this challenge. Here what we are going to do. Step 1. Create a new feature branch. It can be named anything. We just want to practice working with the branching workflow. Step 2. Making a change to a file in the feature branch. Any type of change, then add and commit it to the local branch repo. Then merge the feature branch to the master branch and push the commit to the remote repo. And finally, delete the local feature branch. When you are ready, join me in the next session for this video. Let's take a moment to pat yourself on the back. You made it through the final challenge. Now let's go through the solution together. Step 1. Create a new feature branch. I will start by selecting the branch button. I will name it to my new feature. I will leave the default option to create the branch from the master branch and to switch over to this new branch right after I create it. Select create branch to complete this step. Step 2. Make a change. I am going to make a very basic update. I just need some kind of modification so I can make a commit. I am just going to put a little note at the top of my CSS file. Then I will go over to the file status area in source tree. I'm going to move my main.css file to the staging area and then commit it. Make sure to add your commit message at the bottom of the screen. I'm going to uncheck this option because I don't want to push this change to the remote repo. I only want to commit this change to my local branch. Step 3. Let's merge this feature branch into the master branch. First, I will have to check out the master branch by double clicking it. This is the branch I want to merge it. Then I will click this merge button and select the latest commit from my new feature branch. And I will make sure these three options are selected. Press OK to complete this step. Next, I will click the push button to push the branch commit and merge into the remote master repository. And for the final step, I will delete the my new feature branch. Right click on it and select delete. In the pop-up, the delete remote branch is grayed out because we only made commits to the local branch. We did not push this commit to the remote repo, so there is no remote my new feature branch to delete. Select OK. Now the branch has been deleted and removed from the sidebar. Challenge is completed. Git for collaboration. When working on a team, your workflow will need to be based on a collaborative workflow. We discuss how using branches can be beneficial, even when working independently, but when working with a team, it will be crucial. Branches allow work to happen in parallel. One person can be working on a new feature while any other person can focus on bug fixes, or maybe each person using their own branch so they can have a separate work area. There are ungit concepts such as forking and using pull requests, but these are important to know about when working with others. This is especially useful for working an open source project where the repos may be public, but the collaborator don't have the admin right to push and pull directly into or from the repository. To learn more, check out the opensource.guide or working with team course in this video for more future updates, or see the other video of my YouTube channel Get Siteman for more videos like this. We have covered a lot in this course and I hope you are excited to start using Git with your project. And if enjoyed this and want to learn more about Git or working with the command line, I have a variety of courses in this my YouTube channel Get Siteman. And if you are interested in learning more about tools to improve your workflow, check out my other courses on this YouTube channel. Workflow tools for web developer, or maybe just take a little break and let it soak it for a bit and then come back and practice applying what you learn in real world project, or even reviewing the course. Learning anything new always takes time and practice. Thank you for watching this video and follow along the whole course. I wish you will become professional and pro in your web developer journey. See you in my next videos.